Greetings, grade 9s. Welcome to this Worksheet Cloud grade 9 math lesson where we take a look at factorizing and finding common factors. If you wonder why I often look like I'm laughing silently to myself at the start of these videos, it is because I am. 90% of the time when I start recording, I trip over my own words when I start and I have to click delete and start again. So here we go for the third time this evening. We are trying this lesson. I'm Mr. T, your math teacher for this lesson. A reminder that at Worksheet Clouds, they're all about having fun while you learn, which is why they've instituted their great new rewards hub where you can earn points and earn rewards while you are learning. Frankly, it seems like bribery to me, but if it is going to work to get you to do things that are good for you, hey, why not? And if I was you, I'd be going, yeah, cool, get stuff for doing, get cool rewards for things I have to do anyway, which is cool. Anyway, so you can win rewards like merchandise from Worksheet Cloud, hot chocolate from Nomu, which I am definitely enjoying during these lessons. Excuse me a moment. Or possibly even a chance to win that PlayStation 5. If only I were eligible to win that PlayStation 5, I would say none of you are going to get it, but unfortunately I'm not. So it could be one of you. But let's take a look at today's maths. All right, I'm not even on the right slide. Okay, so we're looking at factorizing with common factors. And our goals for today are be able to find common factors and factorize polynomials. Many nomials is your number of terms or your terms that you have in your thing. So a binomial is an expression with two terms in it. Trinomial 3. And eventually you just go on to polynomial, which just means many terms. Okay, so I'm going to do very little on the slides today, and most of what we're going to do is practice with actual examples, because I think it makes a lot more sense when we start looking at the actual examples. But when we're looking to factorize, what we're trying to do, or what we're doing, sorry, I just had a moment there when I was like, am I actually showing the right thing on the recording? I am. What we're trying to do is find something that all our terms have and take it out, and then we rewrite it with that out. So we've done something like this in reverse when we multiply out brackets. So when we were multiplying out brackets, we looked at this and we said, well, 3 times x is 3x and 3 times 5 is 15, and so we got 6x plus 15. But now we want to go the other way around. So we want to go from 6x plus 15 to the something that's shared on the outside and then what's left over on the inside. So how do we do this the other way around? Well, given that, we ask ourselves, what factors or what things do both of those terms have? So what can go into both of those? And in this case, the answer is 3. The only thing that will fit into both of those is 3. So 3 fits into both of those. Now I ask myself, what will give me 6x when I multiply it by 3? So that would be 2x. And what would give me 15 when I multiply it by 3? And that would be 5. So there we go. 3 times the x. Oops, that should be 2x. Yeah, so 3 times 2x, not x, gives us 6x, and 3 times the 5 gives us the 15. And now that we've got that, I can put an equals, although having left out the 2, I feel I should probably not put an equals. Everybody makes mistakes. As long as we learn from our mistakes, that's not a problem. Okay, so now I'll come back to those after we've done the simple ones. Let's head across to our whiteboard so that we can practice some of those. All right, so I've looked at this one first and I've asked myself, well, cool, we've got this. What can I find that is in both of these terms of my binomial? Bi being that there are two nomials or two terms in our expression. I call it an expression because there is no equal. It is not an equation. Okay. Well, I noticed that what is common in both of them, what both of them have, is a 2. All right. I don't have a common variable because x and y are not the same thing. So what I now need to do is say, well, what would I multiply by 2 to get 2x? And I think that would be just x, because 2 times x is 2x. Plus stays the same. What would I multiply 2 by to get 4y? 2y. And quite simply, that is my final answer. 2 times x plus 2y. Okay, let's look at the next one. I like to start with the easy ones. Teachers generally do. They start with the easy ones and they move on to the more complicated ones. All right, let's have a look at this number 2. We'll start off by looking at the numbers. What is a shared factor of 2 and 6? In other words, what goes into both 2 and 6? 2 goes into both of them. What would I multiply z by? 2 by to get 2z. Well, I'd multiply it by z because 2 times z is 2z. Sign stays the same. What would I multiply 2 by to get 6? That would be 3. Now, what would I multiply? Ooh, no, hold on a second. We can take more out this time because there's a shared number in the z, a shared letter in the z. So not only can we take out the 2, we can actually take out a z as well. I'm using yellow for this, 2z. What would I multiply 2z by to get 2z? Well, that's quite simply 1. And what would I multiply 2z by to get 6? Okay, well, the 2 times something, well, that'll have to be a 3. 2 times 3 is 6. I don't have a y, so I'll have to multiply that by a y. And I already have the z on the outside. So that's it, because 2z times 3y would give me 6yz. Remember, the letters go alphabetically because that's best practice. So yz and zy are technically the same thing because when you're doing multiplication, it's commutable, meaning that you can multiply in any order and still get the same answer. But it's best when we're doing algebra to put things in alphabetical order. So upping the difficulty just a little bit with number 3, I'm asking myself what goes into 36 and 16. I'm going to start with that. Okay, well, yeah, I can see that 4 goes in, 6 doesn't, 8 doesn't. Well, let's try 4. If we end up with something where we still have a common factor afterwards, we can adjust our answer. All right, so I've got to say, well, okay, I've looked at my number. Now I need to look at my letters. What letters appear in both? Well, there's an X there and an X there. This one actually has 2 X's, and this one only has a single. So if we're looking for what is in both of my terms, I have to say, well, there's only one X in both terms, even though the first term has an extra one. Now looking at the next one, I'm looking at my Y. They both have a Y. So 4xy is in both. All right, well, what would I multiply 4 by to get 36? That would be 9. I have 1x, but I need 2, so I'm going to say there's an x there. I have my y already, so that's the end of the first term. What would I multiply 4 by to get 16? 4 by 4 is 16. I already have my x and I already have my y, and that is my final answer. Now, if we'd picked... in fact, let me do that just over to the right. If we had mistakenly said that our common factor was 2xy, what would have happened, shift this over a little bit, is that we would have said, all right, well, we would say it's 18x plus, what did we say, 2. So then it's 8. All right, and I noticed that I still have common factors over there, and that common factor would be 2. So in fact, then I would have to say, well, the extra 2 has to come out there, and there'll become a 4, because 2 times 2 is 4xy. So what do I do to get what would be the joint thing of that, which is 36, and then I'll get my 9x and my 4 at the end. So If you miss it the first time around, you'll be faced with a situation where your bracket then still has a common factor as well. All right, so you can adjust it or you can go back to your thing and start again. Okay, let's look at number 4 where I have no coefficients and I've just gone straight to just having letters or variables. Okay, I have an A in both of them, so I'm going to take the A out. A times what will give me AB? A times B. A times what will give me AC? That would be C. Final answer. Right, we do get bigger numbers. This is where you being good with your times table will help you. So I'm looking at 56x to the 4y squared minus 32xy squared minus 72x cubed y. Okay, I see x's and y's, but I'm not going to worry about that until after I've done the numbers. Okay, I'm asking myself what can go into all of those numbers. So, first of all, my number has to be 32 or less because it can't fit into 32 if it's bigger than 32. All right, so it has to be less than that. I can't make it 32 because 32 won't fit into 56 exactly or into 72 exactly. So it's definitely not 32, but it will be a factor of 32, a number that fits into 32. So I could try 16, which won't work either. So let's see if 8, which is another factor, will work. 8 goes in there and there and there. So let's give that one a go and see what comes out. All right, so let's take out a whole number of 8. Let's see how many x are in all 3 of my terms. All right, I have 4 over there, I have 1 over there, and I have 3 over there. Now the most that is in all of them is 1, because we can't take 2 because this one only has 1. So I'm going to take 1x out, and now we look at the y's. I've got 2 there, and 1 there. Well, 1 is the most because this one has only 1. So we're going to take 1 out over there. All right, what did I multiply 8 by to get 56? 8 by 7 is 56. I've got 1x, I need 4. So I'm going to have an x cubed. I've got 1y, I need 2. So I'm going to do another y. Remember that this means y to the 1, although we don't write it because it's, I suppose, a common laziness of mathematicians. Next term. All right, so we said what will we multiply 8 by to get 32? That's 4. This is where knowing your times tables is good. I've already got 1x and I only need 1x. I need 2 y's, I've only got 1, so I'm going to have an extra y. And we go to the next term. What will I multiply 8 by to get 72? That would be 9. I've got 1x, I need 3, so I need another 2 x's. I've got 1y, I've got 1y, and so I'm done. I'm just going to double check and look back through these and see if there are any more common factors. There aren't, so that then is my final answer. Next one. This becomes, if you're comfortable with what's happening here and you feel like you're A for away and you're good to go, why don't you pause the video, keep going until either you've finished or you get stuck, and then carry on with the video and check if you're right or see what you missed in getting stuck. All right, so I'm going to look first at the numbers in number 6. Coefficients, I should say, which are the numbers in the front. What goes into both? I can see that 4 fits into both of those. So I'm going to take out a 4. Looking at my whole numbers, my A's, I've got 2 A's there, 1 A there. I'm going to take out a single A. It's the most I can manage. 1 B, 2 B's, the most I can take is 1. All right, what will I multiply 4 by to get 12? 4A, 12, that's 3. Sorry, I don't know why I can't with grade 9s. I'm used to doing it with teaching younger grades. All right, then what do I multiply A by to get A squared? That would be an A, and I already have B, B times 1. So you could put times 1 there, but it's meaningless, so we just leave it like that. What do I times a 4 by to get an 8? That would be a 2. A I already have. B I have 1, I need 2. B. All right, so I can double check this. If I multiply out, that 4AB times 3A would give me 12a squared b. 4a times minus 2b would give me minus 8ab squared. All right, so it's definitely right. I did it the other way around and I get the correct answer. Number 7. What's in all of those? Can't be bigger than 3 because 3 can't, well, you wouldn't fit it into 3 if it was bigger than 3. We are sitting with, well, 3 goes into all of them, so let's take out a 3. I've got y to the 4, y to the 3, y to the 2. The biggest I can manage in all of them is a y to the 2. 3y squared, what do I need to multiply to get to y to the 4? That would be y squared, because 3y squared times y is 3y to the 4. 3 times what gives me 6? That would be 2. Y squared times what gives me y to the 3 is y. And finally, I've got 4, and that's already got the y. And I can look at my bracket and check, and you'll see there's nothing else common. Number 8. Right, we're just going to do 10 of these, and then we're going to move on to, I suppose, the next step of complicatedness. And then the last 2 steps are probably where your teachers will really try and extend you and find out who's the best at maths. Or rather, who's really got a good grasp at this and can figure out little secret patterns in numbers. Okay, looking for a common factor for those 3 numbers. I always start with the coefficients. 8 could go into 8 and 24, but not into 20. A little trick to look at is what is the difference between those. So the difference is 4, which means the biggest we can have in terms of number is 4, because otherwise we wouldn't be able to fit into both of those. And as it happens, 4 is the one we will use. Our x's, we have x squareds in 2 and x to the 4, so we've got extras over here, but we can only do that. Y's, we've got 1y, 1y, and 2y's, so we can just do 1y over here. 4 times what will give me 8 is 2. X squareds are done, y is done. 4 times what will give me 24, that would be 6. I've already got 2 x's. There's my x squared to finish it off. Y's are done. 4 times what gives me 20, that would be 5. X squareds are done. One of the y's is there, and there's my answer. Right, checking again, I can't see anything common between those 3 numbers in the bracket or the letters in the bracket, so that means I am done. 14f to the 4, 35f squared. I'll start with the numbers, the coefficients. 7 can go into both of those. F's, the best I can manage is a squared. What times 7 will give me 14? That would be 2. Another 2 f's. What times 7 will give me 35? That would be 5. I've already got my 2 f's. Final answer. I'm done. Right, not too far because I don't want to reveal where we go to next. Last one of these. What can go into all of those? Should be familiar enough that you recognize 5 could go into all of them. 5 times, oh, and let's look at the x's. We've got 3, we've got 2, we've got 1, so the best I can do is a single. 5 times what gives me 30? That would be 6. What x times what will give me x to the 3? That would be x squared. You see why it's so important that you know the basics, because if you're not comfortable with the fact that x times x squared is x to the 3, then this is going to be really hard. And then I suggest rather investing the time in the basics and coming back to this later when you're feeling more comfortable with it. But let's continue. I always do that. I stop halfway through a sum. What times 5x times what gives me 5x squared? That would be just an x because our coefficient's already correct. 5 times what gives me 25? That would be 5. X is already done. There's my answer. I can check and have a look. There's nothing more that will factorize. So we're done. Let's head back to the PowerPoint so we can just look at where this goes next. Okay. Right, so sometimes we find that common factors we can find common factors for some of the terms, but this might lead to other opportunities. So this is actually called factorizing or factoring by grouping. So let's say, for example, we're faced with a cubed minus 3a squared minus 4a minus 12. Now, if I do just the first two together, I look to see what can I take out that's common just between the first two. I'm going to ignore what's in the second half. I'm just looking at these two. So I notice that there's an a squared in both of those. So I take that out and I say a squared times what will give me a to the 3. That's an a. And a squared times what will give me 3a squared. That'll be minus 3 or minus 3a squared. Then I'm going to factorize just the second pair. So I'm just looking at the second half and I see, well, they don't both have a letter, but 4 does go into both. So I'm going to take out, oh no, Mr. Travers, you made a mistake. I should just take this and put it on the whiteboard and do it there. Otherwise, I'm going to be crucified. Let me do it. So a cubed minus 3a squared minus 4a minus 12. Let's go across. A cubed minus 3a squared minus 4a minus 12. Just writing that down quickly. A cubed minus 3a squared minus 4a minus 12. Right, and now I'm going to flick us back to the whiteboard and do it. And I'll also show you what was the mistake I made. All right, I've done it over here. All right, so the first part is all good. I took out an a squared from there. So I took out a squared and I said, well, I've got an a and a minus 3. Now, if I took out a factor of minus 4 or a factor of 4, no, actually, this does work. All right, so I've got a, and then what would I multiply minus 4 by to get 12? That would actually be plus 3, because minus 4 times plus 3 would give me minus 12. So this is not actually what I wanted. I should have done, so we can still factorize this, but we'd have to take out a negative. We'd have to change this sign in order to make it work, and then make that a negative. So as a teacher who doesn't like to complicate things too much, I should have done it like that. So from the very start, rather have chosen that as my number. So I'm going to do that and work from here onwards. Hope that wasn't too confusing for you. You know, sometimes you do something and then you pick up one of your mistakes as you're going, not going to record the whole lesson again because I made a mistake. I should make you feel comfortable making mistakes, because I don't think making mistakes is bad as long as we learn from them. All right, so we're going to say plus 4. Then we take out a, and 4 times what gives me minus 12? That would be minus 3. Now here comes the part that's really cool. Both of my terms, and my terms, remember, are that's one of my terms and that's the other term, have a common factor of a minus 3. So I'm now going to take out a factor of a minus 3, and then I'm going to say, well, what do I times a minus 3 by to get a squared times a minus 3? Well, that then would be a squared. And what do I times a minus 3 by to get minus 3a minus 3? That would be 4. And that now is my answer. And isn't that just beautiful? I think so. I feel it is time to take a moment and have a Nomu hot chocolate study break. Let's be honest, studying sucks. But here at Worksheet Cloud, we make it suck way less. In Worksheet Cloud, you can earn avatars, sidekicks, collectible coins, and then level up all while studying. Plus, we've just added our most exciting feature to date, the brand new Worksheet Cloud Rewards Hub. With Worksheet Cloud Rewards Hub, you can earn epic rewards and unlock entry tickets to win real giveaway prizes, including a Sony PlayStation 5, some yummy Nomu hot chocolate, and some fresh Worksheet Cloud merch. The more questions you answer, the more points you earn, and the more rewards you unlock. Worksheet Cloud makes your studying easier with video lessons, practice exams, practice questions, and study notes. In other words, we're your go-to place for all your studying. Ask your parents to sign you up at worksheetcloud.com today. And if, like me, you have a moustache, you should just check you don't have any hot chocolate in that moustache when you are done having a Nomu hot chocolate break. Okay, so let's head on to one like this down here, and we're going to look at grouping. Now, typically you will find grouping is done when we've got 4 terms, but I will show you when we get a little bit further in the lesson that sometimes your teachers are really asking you to think outside the box with these sorts of things. But let's stick with 4 terms for now. All right, now it might be that it's these 2 and these 2. It might be that it's those 2 and those 2. Might be that it's those 2 and those 2. Right, this is where looking at the numbers and being able to do some of the stuff in your head is going to help. Okay, so I'm noticing Q and R and a Q and an R. All right, I think I need to get rid of the R, so let's do the first 2. I'm going to take out 4 because it goes into 4 and 8, and I'm going to take out R because they both have an R. What would I multiply 4R by to get 4QR? Just Q. What would I multiply 4R to get 8R? That would be 2. Let's look at my next one. I notice I've got a 3 and a 6. Only the 3 is common. Hope I'm not all the way behind my picture. All right, I'll take out a 3, and I'm left with Q plus 2. And now I notice Q plus 2 is common. So I'm going to take out Q plus 2. And then I'm going to say, well, what do I still need to multiply by? 4R plus 3. Boom, there we go. I don't know why I did that. That's not very cool. All right. Next one. Let's see. All right. These powers are quite high, and these ones don't have very high powers. So I think I'm going to try and get those powers down by taking those out. So let's see. What's common between 6 and 4? Let's take out a 2. That's s to the 4 and s to the 3. Let's take out s to the 3 because that's what can fit into both. I'd still need to multiply that by s, and I'd still need to multiply that by 2. Yeah, just 2. These 2, we've got a common factor of 4. So I'd be left with sorry, I missed something here. It's not just s in the previous one, because 2s cubed times 3s is going to give me 6s to the 4. All right, so back to the new one. So 4 goes in 3 times, and I still need an s. And 4 goes into there twice. And spitting out a common factor, we now have a common factor between those 2 terms of 3s minus 2. And we're going to multiply that by 2s cubed plus 4. All right, and there we go. That's our answer. 3 more of these. Okay, now I'm looking at this one, glancing at this one, and I'm kind of going like, these are my 2 terms that have a high x value, and these have 1 and nothing. So difference between the first 2 is 1x, and difference between those 2 is 1x. So maybe let's group these 2. All right, so I'm going to take out a common factor of Let's see if this will work. It's possible it won't, and you might do this in your lessons and decide, well, let's see if it works, let's see if it doesn't work, and you can always readjust and try a different option. All right, so I'm going to go, well, 3 and 2 don't have a common factor, but I can take out an x squared. So x squared, and then I've got an 3x left over there. I've already used my x squared, so just plus 2. Let's look at the other 2 terms now. So plus, well, I can take out a common factor of 2. And then 2 times what gives me 6x? That would be 3x. And 2 times what will give me 4 plus 2. Did work. Found the right one. So we now have a common factor of 3x plus 2. And we got leftovers of x squared plus 2. There we go. Final answer. All right. Looking at our next one. Second last of these before we get on to the more complicated ones. Don't forget, if you are studying with hot chocolate, you should drink it before it gets cold. Normal hot chocolate is much better when it's hot than when it's cold, unless you make it as the cold drink. Okay, looking for common factors. 3 and 6, 4 and 8 rings a bell for me. I'm just going to go with it. If it's wrong, I can always try another route afterwards. 3 goes into both of those. There's an x that's common as well. Multiplied by x to get 3x squared. Multiplied by 2, let's see. Plus 4 is common. 4x plus 2. Yep, managed to get it right first time. It's quite all right if you don't. You're welcome to always make a mistake and go back and try another route. I mean, there's often only 2 or 3 different possibilities. One of them will be right. The more you do these, the easier it will become to recognize what's going to work and what's not going to work. All right, but to finish this up, we've got a common factor of x plus 2 multiplied by 3x plus 4. Number 15, the last one of those. Let me not expose number 16. Ooh, I'm going to have to zoom out a bit, otherwise I'm covering it. Ooh, don't show the next question. Right, so I got messy and wrote all over the show, but notice that there's a difference of 1 in my x's and a difference of 1 in my x's. So I'm going to try and group those two and then those two. All right, common in the first two is 2x to the 2, 1 plus 3x, plus I notice that 5x to the 7 is common. 1 plus 3x. Haha. 1 plus 3x is common. And what we've got in the other bracket is 2x squared plus 5x to the 7. Right. I noticed we could actually find a common factor for those ones as well. But I'm going to leave it like that. No, why not? Let's take it to the next level. All right, I'm going to have to squidge it up a little bit. But let's see. Okay, so we have a common factor of x squared in both of those. So first up, I am going to say we still have 1 plus 3x. That hasn't changed. Now in our next part, we have a common factor of x squared. The numbers, we can't find anything common. So we're going to have x squared. Right, and actually I'll write it in a bit of an odd way first, and then we'll fix that afterwards, just to make sense of it. Then I say, well, I'm going to multiply that by 2 and 5x to the 5. Now that should actually be written with the number that's on its own outside the front. So I will just move this to the front and say x squared, 1 plus 3x, 2 plus 5x to the 5. Right, and we've completed it. Let us jump, oh no, we don't have any more slides to do, but let's go to the next level, which is these ones over here. Now, this is called a trinomial. It's got 3 nomials. It's got 3 terms in it. All right, and I don't see any numbers that are common. I don't see any letters that are common. I'm stuck. I don't know what to do. But now this is where it gets a little bit more sneaky. I suppose sneaky. I think it's true. No, I know it's true to say that this is the same as 5x plus 4x. I hope you agree with me. That's true, right? 5x plus 4x equals 9x. I'm going to leave my other two terms on the side. Now I'm going to have a closer look at what I've left here. Right, I notice that I can take out, an x from these two. So let's do that. I've got an x out. I'm left with 2x plus 5. On the other side, I can take out no letters, but I can take out a 2, which leaves me with 2x plus 5. Yes. Doesn't that just... Okay. I find that is very satisfying. The difficulty is that when you've not been doing this kind of stuff for long, it's difficult to notice that a 9 could be broken up and then broken up into something useful that you can then factorize. So how would you know to break 9 into 5 and 4 and not into, say, 1 and 8? Experience, familiarity with numbers. You can try a couple, but I can tell you that your teachers are going to use these kind. They'll be like the questions at the end of the paper that are hard, where they really want to test who's going to be like the top math students, that kind of thing. So don't worry, I do want to include this in it, in the lesson, because they do come up, and next year they'll be more commonplace. But I do want to just go through them. All right, so I've got 5 examples like this, 4 examples like this, and yeah, the last 2 are a little bit different. 3 examples like this. Okay, all right, so I've got x squared and 7x and 12. And again, and you'll notice that I've separated these in examples by color. I haven't got a common factor for all of these. So I'm going to have to split my 7x up into something. So 4x plus 3x. I'm going to leave my x squared over there and my 12 over there. Take out a common factor for these two, which would be an x multiplied by x plus 4. And on this side, I'm going to take out 3x plus 4. Oh, there, no. Come on, computer, catch up. All right. Must be a connection, a Wi-Fi glitch, because I've actually finished that bracket already. Come on, bracket, finish. There we go. All right. Now I can take that then. I've got a common factor of x plus 4. And my leftovers then are x plus 3. All right, and that's my final answer. Next one like this, 10x squared plus 9x plus 2. Again, maybe you didn't pick it up. You won't be able to pick it up as something common right away, but with a little bit of time, with a little bit of practice, your teachers, when they give you these kind of questions, won't make the thing you need to split too complicated. But these kind might come up, like I said, at the end of the paper. Looking for some common factors here. Well, I notice I can take out 5x. What I'm left with is x plus 1. And on this side, I can take out a 2. So 2. No, that's not going to work. Let's see. Okay, so if I took out this, then I'd be left with 2x plus 1, all right, which is not what I want. So maybe I rather want to go a different way and say, put the 4. This is the same as simply grouping my terms differently, but putting the 4 there and the 5 there. Let's see how that works out. So now we're going to say, well, I've got a common factor of 2 2x, and that leaves me with 5x plus 2. And on this side, I have no common factor. I've just got 5x plus 2. Although that's the same as 1 times 5x plus 2. And 5x plus 2 is common. So I can then say 5x plus 2 times 2x plus 1. And there we go. Right. Moving on to the next level. All right. So this one, I should have given myself more space between these two. I'm going to have to increase the size here. I'm going to have a look across at these, and what I notice immediately is that I can fit 3 into all of those. So I'm going to start off by taking out a common factor of 3. I'm using a square bracket. Maybe that's a bit cheatery of me because I do know what's coming. But I'm using a square bracket to differentiate between square and round. You'll see in a little bit. So 3 times what gives me p to the 4? Well, that's p to the 4. 3 times what gives me 9p squared? That would be 3p squared. 2p to the 3 and 6p. Close square brackets. Now I'm going to look at what I've got inside. So difference of 2, difference of 2. So I'm going to take out, now I've got to leave my 3p on my 3 on the outside, but I'm going to group inside the brackets these two. Hence the reason why I use the square brackets. So I'm going to take out p squared. So then this would be p squared plus 3 minus, and in this side I'm going to take out 2p. And I'm left with p squared minus, nope, p squared plus 3. And that's because a minus times a plus will give me a negative. I do now have a common factor inside my brackets, so this and this. So let me just move up a tiny bit. I'm going to squidge it in there. So I've got 3 p squared plus 3 p squared minus 2. And there is my final answer. I think that's pretty neat. Okay, number 20. This is the most torturous one I'm going to do today. It's kind of really mean. But I do want to just share with you that these kind of things are possible. All right. I can't find any numbers that go into all of those or any letters going to all of those. I can't find a way that I can split that up so that it'll factorize nicely with the others. But no, plus 6x. It is true for me to say that minus 10x plus 6x is minus 4x. Stay with me. The other two terms I'm going to leave unchanged. And now I'm going to look for my common factors. All right, so I'm going to look on this side, and then separately I'll look on that side. All right, so going into this side, I've got 2x, then I've got 2x minus 5. And on this side, I can see a 3 goes into both of those, which gives me 2x minus 5. 2x minus 5. I'm sorry if I'm smiling and laughing, and this is really hard. It satisfies me greatly. Common factor is 2x minus 5, and leftovers or second bracket will be 2x plus 3. There we go. I would be highly surprised if any of you get one of these in your tests this year. In fact, if any of you do, please email me and tell me. And you might only find out if you get a memo afterwards. And once you've done that, in that email where you email me and tell me at Worksheet Cloud, please also mention your teacher's name and what school you're at, because I want to congratulate them for being super mean. All right, just to finish up, we don't learn maths by just watching other people do maths, sadly. We need to practice what we do, what we've learned or what we've seen in order to be able to do it. So what I want you to do is click on the link in the description below the video. That will download a free worksheet from Worksheet Cloud, do the worksheet, practice what it is we've done. And also, just in closing, to remind you, if you want to be eligible for those rewards, such as the Nomu Hot Chocolate, which is keeping me going this lesson, and the PlayStation 5, which is enough incentive to get anyone to study as far as I'm concerned, then you should get your parents to head on over to worksheetcloud.com, sign you up. It doesn't only give you access to the maths resources, it gives you access to resources in other subjects as well, so you can do well at school, which of course is cool as well. But PlayStation 5 and no more chocolate. All right, I'll see you soon. Cheers, grade 9s.